Hello, my name is Youngbin. I go by Ben Lee, and today I'm going to be showing my early submission for week 2 of Agent Forge, a clinical copilot. Previously, we were looking at creating a PDF and document uploader and being able to reference it in the copilot and doing that through different workers, RAG pipeline as well. Now, as you'll see here, I'm going to do my normal auth flow, which is allowing OAuth for this clinician that logged in. And then it's going to kick off this preliminary context gathering summary of this person's medical history and whatever they need to know on first glance. You see here different PDFs that were uploaded. The original query came back with some basic stuff about labs and the references to the specific medical information held on this patient. And here, these are PDFs that were uploaded through the default uploader on OpenEMR. And now we're able to reference them here. And we can specify, for example, which one we'd like to talk about and ask questions about to this copilot, which is an enhanced experience. One thing that I wanted to highlight, so these are different lab reports that were uploaded, different documentation. So I want to show how you could do another upload. Let's see. Sure. This is an example PDF. And let's say we upload this for this patient, and it's going to get the information on that. So you see how this was uploaded successfully. You're able to see the actual content here. And then back into Flow, you're able to reference specific documents. Yep, I reran this with the new document that came in, and you see how the documentation we just uploaded is referenced here. So we can select a specific document that gets highlighted here. This routes the next question through a lane graph supervisor, plus a RAG retriever, fan out in parallel, and the answer will join. So it'll give us a response. So I will say, for example, because I selected this lab, tell me about this lab. It's going to kick off this specified to this scope to this document. And it should do the extraction plus RAG, multi-source citations coming back. And it's a two-pass extractor. There's a deterministic PDF plumber, gives the ground truth, and the vision LLM only selects spans. Substring guard rejects invented values. And the citations are going to be visible with the PDF and prior FHIR labs that were made before. So it'll be a mix of the documents as well as the previous observation citations here. So this here, it specifically talks about the CBC with differential, which is what we had selected. It's going to have the document here specifically that was selected and as a source. And then here they show the medical emoji sign, the scope here, and that's going to be a reference to prior existing medical documentation on them and not specifically the document that was referenced here. And you see the IDs are the same here. That is in reference to this particular document. So showing eval here. There's 50 cases with 5 categories and 5 Boolean rubrics: schema valid, citation present, factually consistent, safe refusal, no PHI in logs, and this is a PR blocking on every MR to main. So it's essentially going to check every time we run this, we make changes. So I did want to highlight some cases here with the citation present, safe refusal, and some of the lower values here. These deliberate adversarial cases where the suite caught actual weaknesses. So I would say that's a thing where you could watch for the regressions, and you could say that the evals are doing their job, and that's a point of improvement for sure that we can make. We're going to switch to LangFuse to look at some of the observability here. Traces. So get today's appointment. We're able to see the chat trace here from the demo run. It goes per request, per tool sequence, and it shows latency for each step as well here. And the token cost, that's costing about, at 0.03 to $0.05 per week 2 turn with Vision. And there's bound to be some costs associated with running Vision and being able to run this RAG pipeline, but I think it's at a manageable level. So I'm going to wrap up by kind of talking through the cost.md and latency. So the submission spec asks for P50, P95, and bottleneck analysis. Numbers here come from the 50 case eval run and laying fuse traces on traffic and the spot curl smokes. These are observed and not estimated. And with vision extraction and whatnot at P50, around 14 seconds. The bottleneck is the vision extractor, 6 to 10 seconds per page on GPT-4o mini, which we're using. And the parallel retriever fan out hides some of the lag latency. Every per request trace is inspectable on the self-hosted length fuse that we're using on the dashboard. Hopefully that was a good explanation.